I'm going to mark up the radii to remind me that that's a radius and that's a radius, and they are of equal length. And yet again, we've got a chord that's missing, which is this chord here, which is dB. Okay, now let's find out what they want us to do. Well, they need us to find the values of both x and y. Well, now we've got this chord BD in, you can see that an angle is subtended to the center and an angle is also subtended to the circumference. And Theorem 2 states that the angle to the center is double that of the angle to the circumference. So we can very quickly say that x must equal 60 degrees multiplied by 2, which is equal to 120 degrees. So we can pop that on here as x being 120. And the reason for it, well, you must just quote Theorem 2. Okay, y. Also worth always having a look for a cyclic quad, but here is one. A, B, C, D forms a quadrilateral on the circumference of a circle. And the special thing about a cyclic quad is that opposite angles add up to 180 degrees. So we can say that 60 degrees plus y must equal 180. And therefore, y equals 180 minus 60, which is equal to 120 degrees. The reason again being that angles in a cyclic quad, opposite angles in a cyclic quad, add up to 180 degrees. And there we are.